anybody remember the name of the first type of quadratic? Difference of squares. And you need to remember that because tomorrow we're going to talk about difference and sum of cubes, which are really easy because you just look it up in the book and it tells you how to do it. So that's nice. So if it's a difference of squares, I factor it into two conjugates. Conjugates are factors that are identical except the sign in the middle is different. So x plus 6, x minus 6. Yeah, you did the first two. Nice work. Okay, now if we were continuing on to find the roots, then we would turn it into x equals plus or minus 6. But today, we don't care about the roots. All we care about are the factors. All right, what about the second one? It's prime. How come? If it was negative 16, it would work. How come you can't factor a sum of two squares? Right. In order to get a positive 16, the factors have to have the same sign, and the middle term doesn't cancel if the two factors have the same sign. So this one is prime. Okay? So next problem. It ends in a negative, so I know that the signs are different. So x minus and x plus. Are there factors of 96 that add to be negative 4? Negative 12 and positive 8. So 12 and 8. Okay. For the next problem, there is a way to simplify it. You can divide by 2, but you have to be careful. If you're looking for the roots, you can divide that 2 out and throw it away entirely. Good. So if I wanted to know where does this equal 0, I would divide both sides by 2, and I would forget that the 2 ever existed. But is 2 a factor of that equation? Yes, so it needs to stick around. If we're looking for all of the factors, the 2 needs to be included. And then it turns it into x squared plus 10x plus 21. And what'd you get, Jordan? Awesome. Did you notice how I said Jordan and she said man? Yeah. Well, you said oh man, but yeah. Okay. So that ended up having 3 factors. 2 is a factor, x plus 7 and x plus 3 are all factors. Okay? So for this one, x minus and x plus, if I go through the factors of 28, 1 and 28, 2 and 14, 4 and 7, does one of those work? No. 4 and 7 look like they're going to work, but the signs are wrong. 1 is positive, 1 is negative, so this is prime. Okay. The next one is tricky. How do we factor the next one? Well, can we factor into 2 parentheses? No, it doesn't have a constant term. If it doesn't have a constant term, then you can't factor into 2 parentheses. So what we look for are common factors. Are there any common factors? 2 would work, 4 would work, and 4x would work. So the greatest common factor among those 2 terms is 4x. Yeah, 4x. So I pull out a 4x. What's left? Just x plus 3. And that's it. Okay? Do we remember how to do this next kind? No? Uh-oh. Multiply these together. Well, first off, can I divide out the 8? No. If I could, that would be nice, but I can't. So I multiply the first one and the last one, and I get negative 40x squared. Now I look for the factors of 40 that add to be negative 18. What do I know about the signs? They're different, and the bigger one is negative. So 1 and negative 40, does that give me negative 18? No. 2 and negative 20, does that give me negative 18? Yes. So I rewrite the entire quadratic, but instead of 18, I use 2 and 20. So 8x squared plus 2x minus 20x minus 5. So all I've done is taken the original quadratic and split the middle term into two other terms. And then I can factor by grouping to get the factors. Does this look at all familiar? We did it a month or so ago. So look at the first two factors. Is there anything in common? 2 and an x. So 2x, what's left? 4x, and I took the 2x away, so what's left? A 1 plus 1. Okay? And then what do these share? A negative 5. How do I know I want to pull out a negative? Because I want my other parenthesis to match this one, and the terms are both positive. So minus 5 times 4x plus 1. So what are my two factors? 4x plus 1, and then 2x minus 5. You okay with that, Jordan? Where did you get lost? Okay. So this is one of the factors, and these two terms make up the other factor every time. All right? Can I pull anything out of that? A 2. So if I pull out a 2, 6x squared minus 29x plus 35. So I can't pull anything else out. So I need to multiply these together. 6 times 30 is 180, and 6 times 5 is 30. So how about 210x squared? Okay, so I need to factor 210. And they need to add to be negative 29. I'm going to skip the first whole bunch of terms because they're going to be way too big. So let's try 10 and 21. Does that make 29? No. 11 doesn't work. 12 doesn't work. 13 doesn't work. What about 14? 14 times 15, does that work? Yeah, that's the one I want. Because I'm not trying to create 58, I'm trying to create 29. So if both of those are negative, that would work. So we have 6x squared minus 14x minus 15x plus 35. Are you okay with this, Jordan? Okay. So multiply these together, get this number, factor this number. Try 1. 1 times 210. Can I use those to make a 29? Not even close. 2 and 105. Well, we're so far from the answer, I skipped all the way to 10. 10 times 21, does that make 29? No. So 11 does not... No, add 10 plus 21. Because they multiply to be this. So this times this is 210. And is 10 plus 21 29? No. So that didn't work. So 11, 12, and 13 do not go into 210, so we skip them. But 14 does. And 14 plus 15 is 29. So those are the right numbers. And I know that both of them are negative because this says same sign and that says negative. So now I just rewrite the quadratic, and instead of negative 29, I insert those. And from here it's easy. All you have to do is group. What do the first two share? 2x. What's left? 3x minus 7. What do these share? How do I know I want to pull out a negative again? Right. It's positive, negative, and then negative, positive. So these signs need to flip. So I'll pull out a negative 5. And I get 3x plus 3x minus 7. So my factors are 2 times 2x minus 5 times 3x minus 7. Go ahead. What's your question, Cheyenne? Oh, yeah. Yeah, this 2 stayed in there. I didn't pull... Oh, I see. So here's a 2x. This 2 is different from that 2. Okay? And this 2 gets matched with the negative 5. So 2x minus 5. Okay? All right. So let's go back to, oh, I don't know, 4th grade. Yeah. So if I had 36 over 30, can I simplify that? Yes. How? I could divide them both by 2. I could divide them both by 6. Why does that work? We're dealing with factors, right? So let's look at the factors. 36 and 30. So 36 is 6 and 6, 2 and 3, 2 and 3. So I could rewrite 36 by doing 2 times 2 times 3 times 3. That is the only way to create a 36 using prime numbers. The 30 is 10 and 3, 2 and 5. So 2 times 3 times 5. Does anything cancel? The 2 and 2 and 3 and 3. So what's left? 6 over 5. Okay? So all I did, I broke down the top, I broke down the bottom, I canceled anything that was on the top and the bottom, and then I condensed the top and condensed the bottom to get my final answer. Well, what if I had, 27 over 20? This is 3 times 3 times 3 over 2 times 2 times 5. That's adding. Yeah, I'm multiplying. Does anything cancel? No. So it's already simplified. So I put all these back together, and my answer is just 27/20ths. I mean, I could say like 10 and 22.5 or 13.5. You could, but we only want to deal with whole numbers. Okay? So let's look at one more. 15 over 6. 15 over 6 would be 3 times 5 over 2 times 3. The 3's cancel, and my answer is just 5 halves. All right? Can we jump back from 4th grade into the present? That was 4th grade. Yeah. You never did it that way, but that's really what was going on. Okay. What about x squared minus 6x plus 5 over x squared plus 7x minus 8? So all I have here are two quadratics, and I want to know, do they share any factors? And if they do, I can cancel the factors and then write a simplified equation. So on top, what do I know about the signs? They're both negative. Are there factors of 5 that add to be 6? 5 and 1. And then on the bottom, x plus and x minus. So plus 8 minus 1. Do they share any factors? X minus 1 and x minus 1. So the answer is x minus 5 over x plus 8. So we have simplified that fraction by finding common factors. Pretty simple. Let's do one that's a little bit easier. Yeah, this is what your assignment's going to look like tonight. Okay, so the top is not a quadratic, right? Can I pull anything out of the top? I can pull out a 4x. So 4x times x plus 3. And then the bottom is 6x squared. Does anything on top cancel anything on bottom? Well, this is really 2 times 2, and this is 2 times 3. So I can cancel a 2 and a 2, and I can cancel an x and this x. So the denominator is 3x. Well, it was 2 times 2 times x over 2 times 3 times x times x. Well, it's not 4x anymore. Good. And remember, when we finish, we have to smash everything back down. So over here, we have a 2 and an x plus 3. So I need to put this back in. 2x plus 6 over 3x. Well, if there was another x plus 3, I would have canceled it. Yeah, if there's not one, then you won't. Okay, good. So that's a good question. Can I cancel those? No. So you mean just do it the same thing in a different way? I mean, this is what you're going to get no matter how you do it. But you could have done it a different way. Go, keep going. Right. You can only cancel if it's in the top and the bottom. This one doesn't have a 3. So no, you can't go any further than that. Well, so you're saying pull the 2 out. Right, but there would be a 2 out here. So this is what it would look like. Because you can't just make it disappear. It has to come out. And then does this cancel that? No. So we have to put it back in. So when I pulled the 4 out, it still existed. It just moved from the inside to the outside. Let's do another one. Okay. Can I pull anything out of the top? 12x squared. So we have x minus 6. Oh, 2. Thank you. Can I pull anything out of the bottom? 3x squared. What's left? 3x, I'm sorry. 3x, what's left? X minus 2. So, what can I cancel? X minus 2 cancels x minus 2. Well, 3 will make the 12 turn into a 4. Yeah, and then x squared over x. One of these cancels one of those. So everything in the bottom went away, and in the top I just have 4x. That's the only thing left. Yes? Well, yeah, this was really 4 times 3. So this 3 canceled that 3. Yeah. Yeah, 2 times 2 times 3. I just kind of did that in shortcut form. Okay? You guys kind of have a handle on that? Let's, um, yeah, let's let you work on your assignment. So I want you to work on page 43 and 44. And I want you to do 1 through 13. And we'll finish this tomorrow. Page 43 and 44. Do problems 1 through 12. And tomorrow we'll finish the rest of the assignment.